Welcome to Math Mini Lessons. This is lesson 45 and we're finally talking about systems of equations. In this lesson, we're going to solve systems by graphing. So here are the things to look for while I'm modeling and while you're practicing. Number one, that you can express the equation. Oops, let me put my highlighter on. Express the equation in slope-intercept form from standard form. Going to be super helpful since we're talking about graphing, and that we can accurately graph both equations. We know how to do that. We've been practicing a lot there. And identify the solution to a system of equations as where the two lines intersect. Now, I am going to add a little hotspot in here because sometimes there is no solution. And that happens when the lines don't intersect. And then there's another point where there's infinity solutions. Why? Because every single point matches because the lines overlap. And we're going to talk about those because it does come up. Even though in the models we're going to do today, we will have one solution where those two lines touch. So here's the high level of what we're going to do today. We're going to look at systems of equations, and that just means two or more equations. For this lesson, we're only going to look at two, but you can have systems that have 3 or 4 equations. And we're going to learn 3 different methods for solving systems of linear equations. There's graphing, there's substitution, and elimination. We're going to start with the easiest one, graphing, for today. And to solve the system of equations, we're going to graph them, and then we're going to use our eyes to find that point of intersection. So once we get that point, that coordinate, that point is going to be our solution. So again, as long as they cross, the two lines touch, we have a solution. Now again, if the two lines never touch, then there are no solutions. And if the two lines are completely on top of each other, they're overlapping, then there are infinite solutions. Let's jump in and look at this first example, and I'm going to try and break down the steps as we go. Solve the system of equations by graphing x plus y equals -3 and -2x plus y equals -3. So the first step I'm going to do, because I'm going to use my graphing calculator, I'm going to go into decimals. I need to have these equations in slope-intercept form. So I have x plus y equals -3. I'm going to subtract x on both sides. So I have y is equal to -x minus 3. Now I can put that into the graphing calculator. And the second one, -2x plus y, I'm going to add 2x to both sides. And I have y is equal to 2x minus 3. So that's it. Let's go to decimals. Great, so I've opened up decimals yet again, and all I'm going to do is I'm going to input my equations. Y equals -x minus 3. That's my first equation. Now notice that there's a blue line next to number 1, so that means my line is going to be blue. And for my next equation, y is equal to 2x minus 3, and this one is green. So I've plugged in both, and here we have it. You can actually see the point of intersection right here. So that's the second thing I'm doing. I'm just graphing the 2 points. So one thing I can do in my work, because remember, we can't always see what happens on a calculator, is I could just feel free to take down the table for both, which means I can go to the first one, hit the little cog, hit table, and go to the second one, hit the little cog, and hit table as well. And now I have both tables there, and I can copy those down. So that is something that we can very easily do. And what I make sure I'm doing is I'm writing the equation on top for both. So y equals -x minus 3. Here's xy. And I'm just taking some points. -2, 1. -1, -2, 0, -3, and 1, -4. And I'm doing the same thing to the other one. Y equals 2x minus 3. Here's xy, -2, 7, -1, -5, 0, -3, and 1, -1. All right, so that even if I don't have my calculator, when I hand this in, my instructor knows where I got those points from. And I'm even gonna go a step further, and I'm gonna identify a common point on my graph. Okay, so let's go to the next part. Next part is I'm just looking for where on my graph both lines meet. We see it on the table that they both have a common coordinate, 0, -3. But look, you could also see it on your graph. It's where those two lines just cross over each other. So all you have to do for this step is look with your eyeballs and find a point of intersection. And what evidence do you use? You can write the solution in your notes. And there you have it. The solution is 0, -3. Now, you could now go a little bit further. I'm going to close this up for a second. I could now go further and check this by putting those points into both original equations. So here's x plus y equals -3, and I can put the points in there. 0 plus -3 equals -3, and that is true. -3 is equal to -3, valid. And -2x plus y equals -3. So -2 times 0 plus -3 equals -3. And once again, 0 minus 3 is equal to -3. So again, optional. I highly recommend it. Since we see it on the graph, we absolutely know that we can plug those in as a check for our work. So hit pause and jot this down. Let's do the same thing again using two new equations. Matter of fact, why don't you try? Let's hit pause for a second, and I want you to try to identify what the solution would be to these two equations once graphing it. Again, if you have Desmos, put the equations into y-intercept form and plug them in and see if you can find a point of intersection. Okay, let's do the reveal. Here is the solution from graphing. You'll find a point of intersection at 0.24. So if you have this answer correct, check it off. Great job. If you had an error somewhere, you just want to see how I solved the problem, we're going to go through the steps together. Now, my first step, as always, is to put the equations into y-intercept form. So that's what I'm going to do. I have -y is equal to -x minus 2. Now, I do want this to be y equals, not -y, so I'm going to divide everything by -1. And you get y is equal to x plus 2. And the second equation, we get y is equal to -2x plus 8. Okay, so I'm opening up Desmos and writing in both equations in slope-intercept form, and you can clearly see on my graph the point of intersection is at 2, 4. Now, if you'd like, you could also create a t-chart where you can actually list all the coordinate pairs from both equations. Remember, you're hitting that little cog and it gives you a little symbol for a table, and it shows you all the coordinate pairs for each equation. And once I have all the coordinate pairs, I can just jot them down into my own table. And as I'm jotting, I'm just looking to see, are any coordinate pairs the same? And if I can find the coordinate pairs are the same, then I know that will be the solution to my systems of equation. And there it is, 2, 4. I can see it on both t-charts, so it is a coordinate pair for both equations. And that's what I love about using Desmos. Not only can I see it visually on the graph, but I could also get the points on the coordinate and add those to my notes, which is really, really helpful for just demonstrating what I know. So that's it for today's lesson. I hope you found this really helpful. I'll see you in the next one. Be well.